What's up guys, I am here to explain LeetCode question number 1962. Remove stones to maximize the total. So in this question what we need to do is we need to pick k we need to pick a pile of stones and then remove k by 2 stones from that pile, which is floor of k by 2 stones from that pile, and we can do this activity k times. In the end we want the minimum number of stones remaining in the array of piles, right? So this is our question. So in the example one, as we can see, we have this array of piles 5 4 9, right? We have three piles 5 4 and 9. So also we have k is equal to 2, which means that we can pick a pile and then divide and remove number of stones by 2 from that pile. We can do this activity three times, and then in the end we want to get the minimum possible number of stones remaining in that array, right? So in the example one, what we can do is we can pick the pile which has 9 stones and then remove 9 by 2, which is 4.5. Floor is 4. We can remove 4 stones from this pile which has 9 stones, and then we will get 5 stones. Okay. Oh, this was the first iteration, but we have k is equal to 2, so we can do it once again. In the next iteration, what we can do is we can pick this pile 5 and remove 5 by 2 is equal to 2 stones from this pile, right? So in the end what we will get 3 comma 4 comma 5, which gives us 12, our desired answer, right? So how to get the minimum number of stones in the end, right? So the main problem is how can we pick the piles which will fetch us the minimum number of stones in the end. So to do that, what we need to do is we need to pick piles such that the number of stones which are removed from that are maximum. Now to do this, what we need to do is we need to pick the piles which have the maximum number of stones at that moment, right? For example, in example number 2, 4 6 6 7, we have three number of we have three turns to remove stones. Okay, so what we can do is if if I pick if I pick this pile which is 3, right? If we pick this pile 3, and we we have to remove one stone from this. Okay, but if I'm removing from this pile which is 7, what we'll get is stones after removing, right? So with so it means that we have to choose the pile which has maximum number of stones at any iteration. It will fetch us the minimum number of stones in the end, because we are removing the maximum possible number of stones. Okay, but how to pick the maximum pile every time at every iteration? Okay, so for this what we can do is we can maintain a priority queue. Okay, so now what is a priority queue? In a priority queue, all the values which are present in it, right, they are stacked such that the maximum value is always on the top, right? If I explain you through this whiteboard, the maximum value will always lie on the top. Okay, just bear with me, it's loading. Okay, right, this is our whiteboard. Okay, this is our pen. This is our priority queue. Okay, and we have 3 3 5 1 and 7. We have these 5 numbers. Okay, if I put all these numbers into this pile, what will happen? We will get 1 3 3 5 7, right? As you can see, 7 is on the top, right? If I remove this 7 from here, we will have 5 at the top, right? If I'm adding 2 in this queue, 2 will be added here, right? This is how priority queue works. We are always accessing the maximum value out of any group of numbers, right? For that we can use priority queue. That's why we are using it here, right? So now let's discuss the now let's start coding as our approach is clear now, right? So first let's declare the priority queue in C++. It's declared like this: priority queue integer. Priority queue will contain integers, right? Let's name it PQ because P priority queue PQ. Okay. Now we need to add numbers to this priority queue, right? So we need to iterate through the entire piles array. PQ dot push. We will push the elements one by one into this priority queue, right? That's complete. Okay, so now we need to remove the stones k times. Okay, so let's iterate k times this, right? While k minus minus. Okay, so this code, this will perform k times. Okay, now what we need to do is we need to pick the topmost pile from the priority queue. Okay, which will be current pq dot top, right? We have picked the pile from the top. Now we need to pop it from the priority queue as well. Now from this value current we need to remove n by 2 stones. Okay, right? This will be our new pile. After removing it will be current by 2, right? Plus, what if the number of stones are odd, right? We need to add one stone as well, right? If the number is odd. So what we can do is use mod operator. Mod. Okay, this will work. So for example, if I have 5, right? So what the final value in the pile will be 3. Okay, so this is how it will work, right? We will then push this into the queue again, right? What if we need to divide that pile further, right? That can also be the case. So we need to keep that new pile into the priority queue. Okay, cool. We have done this, right? Now after doing all the iterations k times, we need to add all the values which were there in the queue. Okay, so that can also be done. While there are elements in the priority queue, we will add all the values. This will be the sum. Initially it's 0, while not pq dot empty. While there are elements in the priority queue, we will consider all the values and then accumulate all of them in the end. So is equal to pq dot top, and then we will remove that and return the sum in the end, the answer that we will get in the end. Let's check the code. I hope it's correct. Yep, the case 1 and 2 are correct here. Okay, let's try to submit this. In the end, I'll also try to explain you through the whiteboard, right? That might also clear some of the doubts that you might have. Let's see. Yep, that's correct, right? So now let's try to understand this via a priority queue, uh, via a whiteboard. Okay. Mm, cool. Mm, right. This is our priority queue, right? And let's take example number 2, right? What numbers we initially have 4, 3, 6, 7. Okay, so now as you can see line number, um, in this loop what we are doing is we are pushing all the numbers into this queue, right? So after pushing the queue will look like this: 7, 6, 4, 3. Cool. This is how our queue will look like. Okay, cool. Now what we are doing is also, yeah, k is equal to 2, right? So we need to pick, so we can pick two piles and remove k by 2 elements from it, right? Size by 2 elements from it, right? So first we will pick this 7. Okay, what it will become 7 by 2 plus 1 because it's odd, right? So it will be 4, right? And then we are inserting that 4 again inside, right? This is our 4 inside. Okay, cool. And the 7 is erased from this queue as well. Okay, nice. Now for the next and the last iteration we have 6. Okay, now 6 is becoming 6 by 2 plus 0, which is 3. Now we are again inserting 3. Okay, well, that's also cool. Okay, okay, nice. Now let's add all these values, right? These are all the converted piles, right? To give us the maximum value in the end. So let's sum all these: 4 plus 4 plus 3 plus 3, which gives us 8. 8 plus 6, 14. Let's check the answer. Wait a minute. Am I not? I think I made some blunder. Just a minute. Uh, just bear with me. Let me find the error in my demonstration. Am I missing something? Oh, okay, okay, okay. Oh, okay, fine. K is equal to 3 here, right? So we can do this iteration one more time. Sorry. So K is 3, right? We can again pick this 4 and divide it by 2. So 4, it will become 2 plus 0, which is 2. Now 2 will be added at the very bottom, right? Now the 4 is also cancelled. Let's sum this. mm, 4 plus 3 plus 3 plus 2, 6, 7, 8, 9, 10, 12. Cool. So that's our answer, which is correct. So that's our approach, right? Now in this, the time complexity is going to be n log n. Okay, because in a priority queue, whenever we are pushing or popping an element, it takes logarithmic time, right? That's how a priority queue works. It's basically a it's basically a maximum heap, right? So it takes logarithmic time. In the case of space complexity, we have linear time because just you we are just storing the values inside a container, right? Which is linear to the number of values, number of piles in this vector, right? So these are the time and space complexities, and I hope you like this tutorial. See you soon with another one. Cheers.